We're going to look at a couple of more polynomials with 4 or more terms, or actually 4 terms, that we're going to factor by grouping. But this time we got to go through a little thought process as to how we can end up with a common factor. And one of the ways that we can do that is something called an additive inverse. Now, an additive inverse means if we were to add the two terms together, or several terms, we'd end up with 0. But, so in other words, an additive inverse, if I've got 2, well, its additive inverse is -2. But let's look at these polynomials. Here I've got 2 minus 2cd plus 8d minus 4. Well, let's go ahead and put this into the two groups, such as this. And so in our first grouping, we've got c minus 2cd. And, well, my only common factor in each of those is c. So we can factor out a c, which then is going to leave us with 1. C divided by c is equal to 1 minus 2d. All right. Now we got this second grouping, 8d minus 4. Well, 4 certainly is a common factor. But if I just factor out a 4 into 8d is going to give me 2d, and 4 into -4 is going to give me -1. But I'm looking for a common factor, which is +1 minus 2d. But if I factor out a -4, then I'm going to end up with -2d plus 1, which I can rewrite as, I'm going to put it up top, 1 minus 2d. And now I've got a common factor, this factor and this factor. And then we can fully factor this thing by c minus 4 times 1 minus 2d. So in other words, the 1 minus 2d, -2d plus 1 and 1 minus 2d, those are additive inverses. And so we're applying the additive inverse by factoring out a -4 in this case. And if we have any doubt about that, how about we just FOIL that? Let's see, c minus 4 times 1 minus 2d, and see if we can come up with something that appears to be like our original polynomial. Well, let's see, FOIL first. C times 1 is c. C times -2d is -2cd. -4 times 1 is -4. And -4 times -2d is 8d. And using that property of equality, I can just switch that around and rewrite this as c minus 2cd plus 8d minus 4. And shazam, we're back to our original polynomial, after factoring by grouping and then foiling it to check our work. Which checking your work is always important. You can check it by foiling, see if you come back to the original polynomial. All right, let's go ahead and look at this second one. I got 3p minus 2p squared. We're going to put that in a group together. And then we got -18p plus 27, and we're going to consider that as a group. All right, so in our first group, I got 3p minus 2p squared. Well, the only thing I can factor out of that is the p. 3 and 2, they're already in their greatest common factor. So we got p times 3 minus 2p. P divided into p squared gives us p. And now I'm looking at this second grouping, -18p plus 27. Well, 18 and 27 both are divisible by 9. So I can factor out a 9 into both of those. But again, if I do, let's see. Well, let's just factor out 9. So we're going to factor out positive 9 plus 9. It's going to give me negative 2p plus 3. And if I just rewrite that as 3 minus 2p, which I can do, doesn't change the value of it at all, I see that I've got a common factor of 3 minus 2p. And so then in this factored form, I've got p plus 9 times 3 minus 2p. Finish off with that parentheses, and then Shazam, there we go. We factored by grouping, and we had to use some additive inverses along the way, or we got additive inverses as part of our factoring. We got to get a common factor from each group. That's our goal, and then we can put the two together, and we will have the factors of a polynomial with 4 more terms by grouping.